Good evening once more. We are now continuing with our lectures on ship propulsion. Today is the fourth lecture. You are welcome. Compliments of the season. Okay, let's start. Thank you very much. Okay, you look at what I'm showing you on the screen. At this point, you can see this, which I showed you before. The prime mover. That is the main engine. This is the brake horsepower at the end of the shaft. Shaft horsepower after the gearbox. Then we have the delivered horsepower at the end of the shaft, delivered to the propeller. So turn to this page, you see them. So we have indicated horsepower, which is inside the engine. The cylinders of the engine is power delivered from the cylinder. This is the brake horsepower measured at the edge of the engine, as I showed you then. Then this is the shaft horsepower measured after the gear. Then the delivered horsepower, which is delivered to the propeller, and then the thrust developed by the propeller, which is pushing the vessel against the effective horsepower, which is the resistance of the ship. So you can see here, indicated horsepower is measured at each cylinder. Brake horsepower is measured by the dynamometer at the end of the crankshaft. Then we have the shaft horsepower measured by the tensiometer at the torsion meter. Torsion meter on the shaft, given by this formula. Okay, then we go up again. We see the delivered horsepower. This is the power delivered to the propeller, measured at just similarly like that of the shaft power, but it's measured at the end of the shaft before the propeller. Then the power delivered by the propeller is given by this formula: power equal to thrust times velocity of advance. Velocity of advance is the velocity of the ship is different from the velocity at which the water is encountering the propeller, and that's why we say velocity of advance. So the ship might be moving at v, but the velocity of advance, that's the velocity of encounter at the backside, is not the same as the ship as the speed of the ship, because of the hull shape and the hydrodynamics around the hull, around the propeller side at the stern. So we have effective horsepower, which we have met several times due to resistance. Okay, then there's a relationship between these powers. When you have indicated horsepower that is inside the prime mover, you see, if you minus all the friction and every losses inside this engine, you will now get the brake horsepower. The brake horsepower minus all the losses inside the reduction gear and bearings will give you the shaft horsepower. Then after all these bearings, the final power that is delivered to the propeller is given here. So it is minus all the losses here you get here. So looking at the text again, you can see it. Indicated horsepower minus losses inside the engine give you brake horsepower. Brake horsepower minus losses in the gearings, in the gearbox, and the bearings in the gearbox give you the shaft horsepower. Shaft horsepower minus losses in the bearings after the tensiometer will give you the delivered horsepower. The delivered horsepower minus the propeller losses will give you the thrust horsepower. The thrust horsepower minus the hull losses will give you the PA. Hull losses is losses due to the shape of the hull. When the hull is very fine, the losses are less. But when the hull is full, the losses are high. When the loss is too high, then you are spending power, but you are not spending a lot of power, but the effective speed of the vessel will be low. So we have here the efficiencies. Therefore, we define the efficiencies. Because where there are losses, we talk about efficiencies. What is the efficiency? The overall efficiency is the effective power against the shaft power. The whole efficiency is the effective power against the thrust power. You see? Propeller efficiency is the thrust power against the delivered power. And this ranges from 0.65 to 0.75. Where we have this and this, where are they coming from? This is what we call open water propeller efficiency. And this is what we call relative rotative efficiency. Because normally when they are doing propeller tests, they do it in open water. The propeller is as if it is in the front of the vessel. So there's nothing, no hull before the propeller. But in actual usage, propeller is always placed at the back. So there is something in between. So this creates this relative rotative efficiency. We have open water propulsive efficiency and relative efficiency therefore. Now shaft line efficiency is given by the power delivered against the shaft power. And therefore, the overall propulsive efficiency is given by, which is given, as I told you before, by the effective power against the shaft power, can be a multiplication of all these efficiencies. From there too, we can have if we collect only these two, we call it quasi-propulsive efficiency. And that is all about the hull powering and delineation of power from the main engine to the propeller. Thank you very, very much.